Alright, so I did a bonus twin. It's actually an older test, but it lines up very well. I think it was actually a quiz. I don't think it was a full-blown test. So here's a multiple select, no partial. Which two of the following are equivalent to 11x squared minus 44? You should know how to factor. You can pull out 11. That'll give you x squared minus 4. There you go. There's a choice. Now, x squared minus 4 is x minus 2 times x plus 2. And, you know, something you can do is you can always, it takes a lot of time, but you can, you can kind of reverse engineer the answers, right? So like this guy, x squared minus 11x plus x minus 11, that's x squared minus 10x minus 11. And then if you for it, you get 4x squared minus 40x minus 44. So it's definitely not that. Standardized test skills, multiple choice tests, you can always do more basic skills to help get the right answer. All right, express 7 cubed plus 10 cubed. Apparently this year, that question for that group of kids was free response, but the pattern was given to them. So A is 7, because it's whatever's cubed. B is 10, and you just plug in. 7 plus 10, 7 squared, take away 7 times 10, plus 10 squared, and you're done. Not a hard thing to do. Let's see, here we have a multiple select, no partial, even says which 3. I don't know if I'll do that for you or not. I might, who knows. That are equivalent to 8x cubed minus 216 using this pattern. So using that guy right there. So if a cubed is 8x cubed, then a is the cubic root of 8x cubed. Cubic root of 8 is 2, the cubic root of x cubed is x. So a is 2x. Now this is what's going on in the background in your brains. B cubed lines up with 216. So b is the cubic root of 216, and you probably have forgotten this, but I know that you're lacking when it comes to numbers. So if I take my 216 and raise it to the 1/3 power in a calculator, I'll get it. B is 6. And I'm just going to plug in. So we have a 2x minus a 6, a 2x that is all squared, plus because there's a plus, 2x times 6, plus because there's a plus, 6 squared. So first off, let's look at signs. Minus, plus, plus. See the signs? Minus, plus, plus. Plus, plus. No, wrong signs. Minus, plus, plus. Minus, minus, plus. Minus, plus, plus. Now this guy might be worth keeping. I don't know. That guy might be worth keeping. All right, so if I square 2x, I get that. If I square 6, I get that. This is definitely a keeper. We're keeping that one. I circled 1 because I can pull an 8 from 216. It's 27. So if I take my original equation and I pull an 8, I get x cubed minus 27. So I'm at 2, but it was 3, so there's got to be one more. Okay, look at this one. This one is for the kid who makes that very common mistake. That one's gone. So by elimination is choice 5. And I can come up with that based on what I've written here. 2x minus 6, I can pull a 2. We decided that this piece right here was equivalent to that. Those are all divisible by 4. X squared plus 3x plus 12. And then if you take 2 and 4 and multiply them together, you get the 8. So plus 9. I don't know why I wrote 12. Plus 9. There you go. Not hard. Factor by grouping. It says for full credit, you must factor it completely. Now, what's different about this one, apparently I had a pretty good group of kids with me that year, is I had it out of order. It was not in standard form. So I'm going to move things around. Both pieces contain a 4x squared. And if I pull a 4x squared, I have an x plus a 4 left. Now both these pieces, the negative x and the negative 4, are divisible by negative 1. And that forces the sign change for the common factor that I seek. So the common factor is x plus 4, because it's 4, I changed colors there. The stuff left over is 4x squared minus 1. And 4x squared minus 1 is that special pattern a squared minus b squared, which is a minus b times a plus b. 2x squared gives me 2x all squared gives me 4x squared. 1 squared gives me the 1. There you go, complete factorization. Use the remainder theorem term which of the following are factors. So if f of a constant is a 0, some constant is a 0, then x minus the constant is a factor. So I'm going to solve these all for x. X is negative 2, x is 1/2, because we have to move over and divide, right? X is 4, x is negative 4, x is 5, x is 5/2. Now, you'd be really kicking yourself in the old butt if you didn't look at the graph. You is holding a graphing calculator in your hand. You look at the graph. That's what you do. So look at there. Negative 1, 4, 5. Negative 1, 4, 5. Check that with the table. Negative 1, 4, 5. You see the zeros? All right, so I need negative 1, 4, and 5. And negative 1's not present. So there's 4, there's 5. Ta-da! All right. Using synthetic division or remainder theorem for that matter to determine if x minus 2 is a factor of the following. I'm just going to do synthetic division. So this is a possible factor. If x minus 2 is a 0, then x is 2, because we add 2 to both sides. Anywho, coefficients here, 1, 1. Y 0. Placeholders. Minus 6. We drop the 1, we multiply and get 2, we add and get 3. By the way, your acronym for this, DMA. 2 times 3 is 6. 0 plus 6 is 6, because I'm multiplying and then I'm adding. And I have made a mistake somewhere. 1, 1, 0, negative 6. I guess I haven't made a mistake. Oh yeah, I remember this. If you do this wrong, you believe that it is a factor. So anyways, 2 times 6 is 12, 6. There's my remainder. So not a factor has a remainder. Okay, so this one was something I designed in case kids messed up. So here's what happens if you do it wrong. If you do it wrong, you forget about your placeholder. 2 times 1 is 2, 1 plus 2 is 3, 2 times 3 is 6, and 0. and you're like, hey, the remainder is 0. It's a factor. And that is why placeholders are important. Placeholders are extremely important. All right, simplify using long division. Right, your answer is the quotient plus the remainder over the divisor. So I've got a handful of kids that struggle with long division. My guess is you weren't the best at it in middle school. That's probably the issue. You guys get promoted into mathematics way too fast, even though you're not ready for it. But what do I know? To turn an x squared into a 2x cubed, I'm going to need to use a 2x. Because 2x times x squared is 2x cubed. And I have to use the distributive property. 2x times negative 2x is minus 4x squared. 2x times negative 1 is minus 2x. And I wrap before I subtract. The x cubes cancel. Negative 2 take away a negative 4 is 2. 1 take away a negative 2 is 3. And I'm going to go ahead and bring down that negative 4. New goal is 2x squared. I just need a 2. So plus a 2. 2 times x squared, 2x squared. 2 times negative 2x, minus 4x. 2 times negative 1, minus 2. And again, right before you subtract, the x squareds are gone. 3 take away a negative 4 is 7. Negative 4 take away a negative 2 is negative 2. And you're done, because you're not going to turn x squared into an x. It enters 0 times, or maybe x to the negative first times, which is beyond what we're doing right now. So our remainder is 7x minus 2 pieces of x squared minus 2x minus 1. I think I can finish this little bonus twin. List the potential zeros of g of x, which is 9x to the fourth, blah, 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 minus 4. So when I did this in class, I said it was factors of the back. Maybe I should use the word but. Factors of the butt, I don't know, over factors of the front. So this is the back number 4. Factors of 4 are going to be plus or minus 1, plus or minus 2, plus or minus 4. Sitting over the factors of the front, which is a 9, which is plus or minus 1, plus or minus 3, plus or minus 9. So I'm going to take everything and divide it by this one right here. It's the first thing I'm doing. I'm dividing by 1, or plus or minus 1, plus or minus 2, plus or minus 4. All right, now I'm going to divide everything by a 3. 1 over 3, 2 over 3, 4 over 3. Lastly, divide everything by the 9. All right, plus or minus 1/9, plus or minus 2/9, and plus or minus 4/9. And that looks to me like it's probably this guy right here. I think I wrote it in increasing order or something. I don't know. Maybe decreasing order? No, I don't know what I did. But it's that guy. All right, moving forward. Find all the zeros of x cubed plus 8. And it says look at the graph to find the real one. It does have a real one. Or just set it equal to 0. Because you can do that in this example. But anyways, let's go to y equals and play along, kids. Don't just sit here and act like you can do it when it takes you 5 minutes to type in x cubed, because you can't. You're slow. Zoom 6 the way you were trained. And you'll see that you have a real 0 at negative 2. It's right there. That's where x is negative 2. So I know that one of my zeros is negative 2. And I also know that Milbrath has been trying to teach me synthetic division for the last week. I have 1x cubed placeholders. There is no x squared and there is no x. Okay? And then again, drop, multiply, and add. I drop the 1. Negative 2 times 1 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is 4. 0 plus 4 is 4. Negative 2 times 4 is negative 8. 0. All right. What am I left with? I have a remainder. I have a change color, a constant, an x, and an x squared. I have x squared minus 2x plus 4. And now I'm going to hit this thing with the QF. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So looking real quick, a is 1, b is negative 2, and c is 4. Opposite of a negative 2 is a positive 2. Plus or minus, if you're button pushers, make sure that you wrap there, because if not, you're going to get the wrong answer, because it's going to tell you negative 2 squared is negative 4, and it's not. A is 1, C is 4. It's all sitting pretty over twice a 1. All right, what's in that radical? In that radical is a 4 minus a 16, which is a negative 12. Both pieces over 2. The root of negative 12 can be thought of as the imaginary root of 12, and the root of a real 12 can be thought of as the imaginary root of 4 times root 3. And the real root of 4 is 2, so 2i root 3 is what we're left with. And that's sitting over a 2 from up here. 2's cancel. So we have 1 plus I root 3 and 1 minus I root 3. And these guys, the vocab word, are conjugates. They are conjugates of each other. Polynomial has 4 known zeros. What are its remaining 2 zeros, and what degree is the polynomial? So the idea here is weird zeros have conjugates. And these are not weird. Those are not weird. A negative number is not weird. All right? These guys, they're the weird ones. This guy is literally irrational. And this guy is literally complex. All right? They're the weird ones. One of them's complex, one of them's irrational. So we're going to use our theorems about these. Weird zeros have conjugates. So if root 2 is a 0, negative root 2 is also a 0. And if 5 minus 3i is a 0, I don't know why I wrapped it in parentheses. A lot of times you see that done. 5 plus 3i is a 0. All right, so these are the remaining 2 zeros, that one and that one. And what degree is it? Well, we're going to count the number of zeros. 1, 2, 3, 4, 5, 6. So it's a 6th degree polynomial. Easy peasy, lemon squeezy. All right, 11. How many real zeros, real or imaginary, does the polynomial 5x to the 108th minus blah, blah, blah plus 27 have? X to the n has n zeros. And again, x to the n is the first term in standard form. So it's going to be this guy right there. It takes a special kind of special to miss number 11. All right, that's all I'm going to say about that. Determine the power function, the real and complex zeros, and their multiplicity of f of x equals, and then classify the zeros as touch, cross, or imaginary. So there's a lot of things in here. Start off with the power function. The power function is the first term in standard form. That's what she is. So what I'm going to do basically to create this is I'm just going to throw away this stuff right here. Okay? I'm not going to sit there and work that out. I have 3x times an x that's cubed times an x times a 2x to the fourth. And this is going to take a little more work. 3x times x cubed is x to the fourth times that is x to the fifth. So there's 3x to the fifth from these pieces. Now 2x to the fourth is going to create an x to the fourth, but 2 to the fourth, that's 16. So that's 2 times 2 times 2 times 2. So I have 3 times 16, which is 48, x to the ninth. There's your power function. That determines end behavior, by the way. The next thing is the real and complex zeros. You're going to do that with the zero product property. You know, you ought to, well, actually, I say you know it. I grade your stuff. You all don't know it. I don't know what you've been doing for the last month and a half. But 3x must be 0, therefore x is 0. Understood exponent of 1 says the multiplicity is 1. Okay. Odd multiplicity crosses the x-axis. This is a cross. Next up, we have this guy. X minus 1 is a 0. X must be 1. The exponent is a 3. The multiplicity is 3, which, by the way, is still odd. So we cross. Now I'm looking at x plus 2. It must be a 0. So x is negative 2. The exponent on that factor is an understood 1, which is odd, which is a cross. All right. Something's missing on this. I need to add something in because I remember I was going to change this for y'all because to make it line up with your test. We have 2x minus 1, which is a 0. So x must be 1/2. The exponent is a 4, which is even. So even multiplicity. We touch the x-axis. All right, now we need to add in another factor here. Which would change my power function, wouldn't it? Okay, so I'm adding in x squared plus 3. That's going to add in an x to the fourth, which is 48 x to the 13th. Now I need this here because your test talks about the imaginary, so it needs to be added in. This 2 is the multiplicity for both of these things. Of course, they're both going to be imaginary. But that exponent right there is the multiplicity of the factor. This particular factor creates 2 distinct zeros. So x squared plus 3 is a nothing. And move over. X squared is negative 3. X is plus or minus the root of negative 3. So x is plus or minus I root 3. All right, so that needs to be fixed. And I'm going to do that real quick. And just because you're going to be like, Milbrath, you missed a question, let's put a little note box here. All right, so now that'll save me from being bothered. All right, back to what I was doing. 13, the graph of polynomial has 129 turning points. What is the least degree the polynomial could be? So the theorem is that x to the n has at most n minus 1 turning points. Now this one has 129 turning points. Because it's 129 turning points, it has to be x to the 130. X to the 130 would have at most 130 minus 1 turning points. And 130 minus 31 is 129. So x to the 130th power. Easy question, really easy question. 14, this one's laid out better than the actual twin that I gave you because it's more along the lines of what's on your test. You got a graph, you're going to state the zeros, how many times they happen. You have a 0 at -1. It's multiplicity, it's a crossing, so it's at least 1, it's odd. You have a 0 at 1. It's a touch. Its multiplicity is a 2 because touches happen twice or more. 2, 4, 6, 8, they're evens. And you have a 0 at x equals 2, and its multiplicity is a 1 because it's a crossing. So remember, cross, m equals 1, touch, m equals 2, and I should say at least. At least. All right? Based on your zeros and multiplicity, the polynomial is at least what? So we have a 1, a 2, and a 1. 1 plus 2 plus 1 is 4. It's at least a 4th degree polynomial. State the least degree based on turning point theorem. There are 1, 2, 3 turning points, 3 TPs. That doesn't stand for toilet paper. So we have to be at least x to the 4th because the theorem which I just went over said x to the n has at most n minus 1 turning points. So 4 minus 1 is 3. By the way, it's behaving like this because the next thing is end behavior. This thing is starting low and ending low. That is the definition of a negative x to the even. And I'm pretty sure negative x to the 4th fits that. So these things right here, they are all reinforcing each other. All right? Everything is reinforcing each other. Everything. Now, there's some stuff in here that helps me. Negative. See the negative? I can't be this guy. It ain't happening. Is there anything else that helps me? X to the 4th. See the 4? The exponents here are 1, 1, and 1. So 1 plus 1 plus 1, last I checked, was 3. I can't be this guy. Oh yeah, the negativity. I can't be that guy either. Negative. So these positive ones disappeared. The 4th degree at that, I took it from a 1 in 5 guess to a 1 in 2 guess. All right, so let's talk about some things here. Our multiplicity. X is -1 is a factor of x plus 1, and it happens one time, so we have the understood one as an exponent. So this one's passing, this one's passing. X equals 1 is the factor x minus 1, and it's a square because the multiplicity is 2. So this one just failed. I didn't even have to find the a value. Now, to find a, though, I already know it's going to be e. But to find a, that's where this point comes into play. I didn't need to because I have good test-taking skills, but I didn't have to do it. I'm going to take my factors, x plus 1, x minus 1 squared, and then x minus 2, and I'm going to plug in this point right here. Everywhere I see a y, I'm a 4, and everywhere I see an x, I'm a 0. So 0 take away 2 is negative 2. Negative 1 squared is 1. 0 plus 1 is 1. Still have an a. Still equal to 4. 1 times 1 times negative 2 is negative 2. So 4 is equal to negative 2a, so a is negative 2. And again, the correct answer choice was E. All right, this should be technically number 16. Solve the inequality x cubed plus 3x squared minus 16x minus 48 less than or equal to 0. It takes an x squared from both, and that'll leave you with x plus 3. This is just factoring by grouping. I'm going to pull the negative 16, and that's going to change that sign to positive, still less than or equal to 0. Now we have x squared minus 16. The common factor was x plus 3, still less than or equal to 0. And now we just continue to factor x minus 4, x plus 4, still less than or equal to 0. I question, I know that we love to push buttons in a calculator or whatever, but the truth is, a person who's good at math can do this quicker by hand than pushing buttons in a calculator. I know you don't believe me. That's because you're not that good yet. Get better. So negative 3, negative 4, positive 4, starts low, ends high. Multiplicity was 1. All of these are crosses. And the deal is less than or equal to 0, which is touching or below the x-axis. So all that territory right there. This guy says x is less than or equal to negative 4. So I'm looking for the negative infinity to negative 4 deal. This is just gibberish. That's for the complete moron. This one says I'm between negative 3 and positive 4, which is that notation right there. So choice A. Polynomial has roots at x equals 0, multiplicity of 2, and x equals negative 2 plus root 3. What is the equation of the polynomial in standard form? So remember your conjugate theorem. We also have negative 2 minus root 3. So this guy has a multiplicity of 2. Again, I'm going to write x minus 0 squared, which just reduces to x squared. And then I'm going to do the things I've talked about. It should say multiplicity is 1. If negative 2 plus root 3 is a 0, then x plus 2 minus a root of 3 is a 0, or is a factor, sorry. And the conjugate was negative 2 minus a root of 3, so x plus 2 plus root 3 is also a factor. Signs change, kids. We've been over that. All right. This looks really bad, but it's not. I promise you it's not. I have, if I x everything, I have x squared plus 2x plus x root 3. Then I'm going to 2 everything. So plus 2x plus 4 plus 2 root 3. And now I'm going to negative root 3 everything. So minus x root 3 minus 2 root 3. A negative times a positive is a negative. A radical times herself is the number inside. And I'm going to clean it up. I still have an x squared out front, by the way. I've got that x squared plus 4x, x root 3 negative x root 3, 2 root 3 negative 2 root 3, 4 minus 3 is 1. And then I'm just going to x squared everything. And that's going to be an x to the correct answer is not here. Not there. X to the fourth plus 4x cubed plus x squared, which was not present in those answer choices. But there you go. There is your bonus twin. Do it. It'll help you out. Don't blindly copy. Don't just give some kid your work either. Stop doing that. Let them fail. They need to fail. Let them learn their lesson.